Hello friends. Today we will discuss the meaning and concept of uniform plane waves. Now, first let us discuss the definition of a uniform plane wave. Now, an electromagnetic wave, okay, an electromagnetic wave propagating in suppose z direction. This is suppose, okay, it may be x direction, y direction, but here we are assuming z direction is said to be a uniform plane wave, if its fields that is E and H are independent of x and y directions. Okay, an electromagnetic wave propagating in z direction is said to be a uniform plane wave if its fields E and H are independent of x and y direction. Okay, in other words, second definition is that a wave in which E and H lie in a plane, and have the same value everywhere in that plane, Okay, so first thing is, suppose it is moving along z direction, then its fields E and H are independent of x and y direction. This we will prove here. Second definition may be, if E and H lie in a plane, then these E and H have the same value everywhere in that plane. Now, what is uniform plane wave? Okay, now this is basically a wave. Okay, and suppose it is z direction, it is y direction, and it is x direction. Okay, and suppose it is E component, fine, and it is H component, magnetic field component. Okay, now if the wave is moving along z direction, then E and H are independent of x and y direction when it is moving along z direction. Okay, for a uniform plane wave propagating in z direction, then has no z components of E and H. That is, we will prove here Ez equals to 0 and Hz equals to 0. Ez equals to 0 and Hz equals to 0 because overall the wave is moving along which direction? Z direction. Okay, now let us discuss about the proof. Now, as the plane wave equation in terms of free space equation, we have already derived del square E equals to mu naught epsilon naught curly square E by curly T square, or we will expand it, plus y square z square mu naught, it is epsilon naught also, epsilon naught curly square E by curly T square. Now, as per the definition of uniform plane wave, E is not a function of x, E is not a function of y. Therefore d square E by dx square equals to 0, d square E by dy square equals to 0, because E is not a function of x, E is not a function of y. Therefore, above wave equation will become d square or curly E square by curly z square equals to mu naught epsilon naught curly E square by curly T square, or curly square Ex, curly square Ex. Now we will not use this symbol. By curly Z square I cap, by curly square E by curly Z square J cap, plus curly square E, we will not use this symbol, curly Z square K cap. This equals to mu naught epsilon naught curly square Ex by curly T square I cap, plus curly square Ey by curly T square J cap, plus curly square Ez by curly T square K cap. Okay, now equate the respective component, that is x with x, y with y, and z with z. Respective components, it will become curly square Ex by curly Z square equals to mu naught epsilon naught curly square. Okay, this is curly square Ey by curly Z square mu naught epsilon naught curly square Ey by curly T square curly square Ez by curly Z square mu naught epsilon naught curly square Ez by curly T square. Okay, now this is our equation number 1. Okay, this is our equation number 1. Now from Gauss law, for free space, del dot E is equals to 0. Okay, or curly Ex by curly X plus curly Ey by curly Y plus curly Ez by curly Z equals to 0. Okay, this is from the Gauss law or Maxwell equation, Maxwell first equation in free space. I have already derived it. Okay, so as E is not a function of X, E is not a function of Y. Okay, therefore curly Ex by curly X equals to 0, curly Ey by curly Y equals to 0. Therefore curly Ez by curly Z equals to 0. This is our equation number 2. Now put equation 2 in equation number 1. Put equation 2 in equation number 1 here. Okay, so curly square, if we put equation 2 in equation 1, then curly square Ez by curly T square equals to 0. Okay, now therefore this is a differential equation. Therefore Ez should have one of the following solutions. Number 1 solution may be, that is Ez equals to 0. Number 2 solution is Ez is a constant with time. Ez is a constant with time. Number 3 is Ez increases uniformly with time. That is Ez equals to Kt, where K is constant. Okay, if Ez is a constant and Ez equals to Kt, it will not be part of wave function. Okay, if Ez is a constant and if Ez equals to Kt, it will not be part of wave function, wave motion. It will not be part of, it will not be a part of wave motion, because here it is a constant and here it is variable, it is increasing with time. Okay, therefore Ez will be 0. That is first solution. Similarly Similarly, Hz equals to 0. Now it proves our definition that components of electric and magnetic fields of a uniform plane wave in the direction of propagation are 0. Okay, this solution is only possible. Now this is about the uniform plane wave, and we will discuss about the general solution of uniform plane wave in the next video lecture. Thank you. Thanks a lot.